Good evening and welcome to this evening's webinar, Exam Readiness, Mathematical Studies and Specialist Mathematics. My name is Rodney Anderson and I will be your host for this evening's webinar. And one of the panelists tonight is Carol Mole, as you see in front of you. She's been teaching mathematics for a long time, but she's a legend. And hello Carol, are you there?
I'm here, Rodney. How do you do?
Thank you. And the first presenter for the night is John Beaumont. Hello John.
Good evening, Rodney. Good evening, Carol. Good evening, all.
Hi there.
Okay, and as you see in front of you is the technology fanatic, and he loves the TI-nspire and the TI-84, and I'd like John to commence with this part of the webinar tonight. So over to you, John.
Thank you, Rodney.
There we are, John. We're seeing your screen now.
Lovely. Thank you, Rodney. Well, good evening, all. And as Rodney said from the title, we're going to be focusing tonight on the SACE and NTCET, which is the same exam for mathematical studies and specialists. My main focus tonight will be on the studies aspect, and then Carol will take the baton from me and continue with the specialist. I've split my screen like this just so that I can show you how I'm working with the calculator using TI SmartView, and at the same time show my PowerPoint because I've got some questions there. But obviously I could have either of those bigger if I was in the classroom context. I'm also going to stick with the CE SmartView version, which will give me the advantage of having color and better pixels. But obviously everything I show you on here can be done on the 84. And if you do have SmartView in your classroom, you're able to get the free upgrade to the CE version anyway. So an area that all teachers from the Northern Territory in South Australia are aware of and should continually use is obviously the SACE website for many resources and advice and the learning assessment plans, etc., but also to find the Chief Assessor's reports. And I find these a real valuable tool to develop my teaching, both to talk to the students about students around Australia, and around the two states, and what answers they give, and the hints that the Chief Assessors can give us on how to do certain questions. So I've taken some from the Chief Assessor's report for 2013 studies that is focused on the technology aspect. And it's very interesting that it talks about how students need to be more efficient when they use the graphics calculators and the technology rather than just using it. Looking at not only being efficient, but the marks that are associated with those questions, and we'll focus on that in a minute on a question 12 from that year. And finally, also setting up a sensible view window. Most of those are controlled by the question, but others students need to work out for themselves. And this, again, is a question that I'll look at in a minute, is obviously putting in the asymptotes. They don't come up naturally on the technology, and students need to be aware of that when they're working through these questions. So this was the question 12 that they talked about. So let's start off and we'll graph it. So we're going to Y equals. I'm leaving those two there. There's something else I'm going to do in a minute. And let's go down to this nice pink one. Is it pink, Carol, or is it fuchsia? What colour would you say
pink.
that is?
I'd say pink.
Okay.
Yeah.
I know that.
Or mauve if you want to be fussy.
Okay, I'll give you that. I'll bow to your better judgment on that one. So if we graph this just like the question says, and I encourage my students as soon as they have a question and they see an equation to actually graph it. There's a big hint there already where there's going to be an asymptote, and again talking to students about why that would be the case. So that looks good to me. Before we press graph, let's set the window up exactly the same as the screen. So -6 to 6, going up by 1. The marks on there are the same. From -4 to 2, going up by 1. And let's have a look at this graph. And there we go. So obviously the students have got to draw that. There's 3 marks available for that. It does say in the question that they've got to clearly show the axes intercepts and the vertical asymptote. Well, there's a massive clue here, but the students can see that there is a value coming down here, so you'd expect them to put a dotted line in there. We can go to table and see that, oops, I've still got it on, so I'm just going to go to mode for a second. I've still got it on float for 2, so I was doing some work to do with financial maths, and I wanted it to be for dollars and cents. So there we go. It's come up like this with the fractions because of the way that I typed it into the calculator. But I can change that if I want to. But I'm happy with that for now. It doesn't matter too much for me. We can see that 0 is okay, 0 gives 0, and there's that -1, there's that error. So again, the students know there's going to be an asymptote coming down here. Okay, we need to be mindful of the intercepts. Well, we know there's one there at 0, 0, just saw that one a second ago. Students need to make sure they mark the maximum, which we all know how to find. And I'm pretty lazy on how to find the maximum. If it's lazy is the right word, I use that word.
I think
I'm not sure
it's
it's the right
time
word.
efficient
Thank
use of
you,
technology.
Rodney. I appreciate that. I think I did that right. There we go. And it says, is it between those two? And I say, yes, it is. And there we go. The maximum is at 1.00, and the y value is a half. So we can put a cross there at that value. And then the students, if they want to read more values off, they can do. And they can equally then graph it, making sure they're not lazy with those graphs. I've seen students who just rush it and lose at least 1, if not 2 marks so unnecessarily. All right, moving on with that question. So then it says find the x-coordinate and y-coordinate of the stationary point. Okay, so it's only 1 mark. This is back to what we said before. Well, it's the stationary point, so there we go, we found it. And we'll be able to write that down again, encouraging the students to think about why is it giving us this. And that is 1. And now consider this function. So it's slightly different, and find the x and y coordinates of their stationary point. Well, they could equally just go back into here. They could type it in again, or they could just amend this one and change the 2. And obviously this question is leading on to other things. If you want to look at this question later yourself, it's going on to other things. There it is there. And if we press graph now, we can see it's going to change some things and not change others. They're going to find the stationary point again, and away they go with that question. But again, it's only worth 1 mark. So here's now the Chief Assessor's report from 2014, and this links specifically both in the general comments to question 17, but also some specific comments to question 17. And it said that this provided a lot of challenges, as it should, because it was the last question in the exam. And I think there's some fantastic questions in the SACE papers. I always admire them. I always find them really interesting to do, both for the students and for myself, and as a teacher explaining them. And I think that the nice thing about the papers that we have and the way that the SACE and the NTCET is set up is balancing the visual aspect, the real life aspect, and the mathematical aspect. And I think that therefore the technology and using the TI-84 really supports that nicely for the students to really understand what they're doing with these questions. All right, so here again they're talking about this graph, and they're talking about how if students just take it straight off the calculator, they may only get 1 out of 3 marks, and they're missing these asymptotes again. So if we go through that, here's the graph again.
John, the other little clue is that there'll be an error statement in the table which will be showing in a tick, isn't there? There's always an error statement for that x value that gives you the asymptote.
That's right, yep, exactly. So that's obviously coming up in a minute with that other question, and that's what was on the other one as well. When you type this one in, I'm just going to turn the other one off. I don't know if you noticed, but I turned this one off so it wasn't a black square. I should have talked about that. Sorry, I was in autopilot. We're also going to set it up exactly the same. I'm using green this time. Hope these colours are coming through okay, Rodney?
They're looking very nice.
They are? Great.
You're
okay,
a colourful character, aren't you, John? You're a very colourful character.
When we get to the colour, I was very happy, and really helped my teaching to just take it to that next level in terms of helping the students understand which line relates to which, rather than having the dashed line or the thick line. So with this one, I don't know what the window is, but I'm not too stressed about it. I'm just going to go zoom standard, the old bog standard one, to work out what it could be. All right, and there we go. All right, so I could say to students, well, okay, it looks like there's a maximum there, and we should know that because it's a cubic. We should be aware of what that is. Just nice to the visual supports what they should know about that. They should know that it crosses at 0, 0 because there's no constant when x is 0. So we could change the window if we want to go a bit higher. Let's just do that, just because we can. And I'll have it going up every 4, just again, because I like it. Oh, that was a bit, what did I do there? There we go. Best to change the, there you go. 2's not going to help me, is it? Let's go to 20. There we go. Beautiful, absolutely beautiful. So here we go. For what values of x does fx equal 0? Well, I've talked about here how we can find it. And again, I think the students need to be aware of all these ways and let them choose which one suits them. And I think if they're aware of all of them, at times all of them will suit certain questions, and other times some will suit questions better than others. The green part here is the feedback from the Chief Assessor's report. So they pointed to one solution or the other, but not both as required. There's a giveaway here. There's not a giveaway in the mark, but there's a giveaway here and says the values of x. It doesn't have it in brackets. It actually says the values of x. So one way would be for the students to calculate the zeros. So left bound, well, let's take this one over here for a minute. 1, 2, 3, 4. Let's go, oops, no, we don't want to do 5. Let's do 4. That's looking good. And to 6, well, I reckon that's looking like 5 myself. And lo and behold, it is. And wonder if it will give us the other one. Second calc. The 0. What do you reckon, Carol? Do you think it's going to give us the other one?
We'll be interested to see if there's a sign change, won't there?
Let's have a guess.
-1 to 1.
And it's thinking about it. Do you see up here? I was a bit impatient. It's going through it. And there you go, no sign change, which again is a nice thing for the students to think about and go, hang on a minute, why is it giving us no sign change? I find that my students so quickly get off of this screen, they don't even give it any time, and they definitely miss the go-to part, which sometimes comes up. But they're not really, I think they need to bear this in mind and think, well, what's going on? What does that sign change actually mean? So it doesn't give us a second one, which should give a hint that there were two, but we can go to table. And, yeah, there's 1, 0, 0, because that's okay. The y value is 0. And there's the other one, 0, 5. So they can get it from there. And if we just quit that for a second and just show this app, which, again, I'm sure that all teachers are aware of and have used it many times, which is PolySimp, number 8. We're going to use polynomial root finder, not the simultaneous equation solver this time. The order is order 3, because it's a cubic. Always like students doing that. Notice these tabs here are linked to above the function keys up here. I'll just show you that quickly. So let's hide that large screen. I didn't have it like this because they're obviously linked to the F5 here, the F4 and the main. So when you teach, if you use this to teach with, it can be for the students a little bit confusing why you're pressing this button here if it's not above. So I'm going to go next. I'm now going to change the view back so it is to the side, and we have that larger display. What have we got? We've got -1. Make sure we use the negative, not the, is it a plus or a minus? Well, it is a plus, that's good. And it's a 5. And in fact, all that is 0, 0, and 0. And we're good to go there. And let's solve that. So that's F5 again. And there we go. It does give us there's that double, which we should be aware of. So it gives it there. X values are 0 and 5. So nice to show how we can use both those functions just to work that out. Okay, so there again, talking about where is it greater than 0? Well, we're talking to the students about, oops, got to get out of that, sorry. Let's go main. That's not going to do it for me, is it? Let's go main. Let's quit the app, number 6. All right, so again here, the Chief Assessor's report said that the interval was not well described, with a lot of students saying X is less than 5. I think here again the table really helps the students. We're looking for where it's greater than 0. Well, here this is not greater than 0, it's equal to 0. So we know it must be less than 0 and equally between 5 and 0 for the two values. So hence the reason why there's 2 marks. And again, just these little marks that can get dropped by the students can in the end have a big impact on their results. So I use this a lot when my students have done practice papers and show them this and see whether they fit into this category. Hopefully they don't, and it reflects on me as their teacher. Okay, so here we go. This is part B of the same question. Again, there's the Chief Assessor's report down the bottom. I'm just going to go down and we'll choose another one. I'll leave these all here for now, it doesn't matter. Turn that one off. Let's go the old ochre, the Northern Territory. Okay, and we've got LN, bracket naturally comes up already. Now that is that, isn't it? So let's just show this off. I'm going to go alpha F4 to come up with the quick keys, and we want Y5. Just being a bit lazy, and that's correct. Yep, and we're all good with that.
Time efficient, John. Time efficient.
Thank you. I do. It saved me at least 4 presses there, Rodney. So thank you. Let's go to my window again and set it up so that it's exactly the same as what the question is saying. And if I wanted to, I could also put the grid lines on it. So to put the grid lines on it, I was going to press mode, and I don't think it is in mode. No, I didn't think it was. It's in format, which makes much more sense. And I could turn the grid lines on. So why don't we do that for this one? So come across, enter. Now it's going to give me the grid lines every one, because that's what I set my X and Y scale to be. There we go. All right. But I could equally change it so that if I went into my window and changed the X scale, oops, missing the button, that didn't help, to 0.5 and 0.5, we would get a visual that's exactly the same as this here. Now, obviously, ours are rectangular looking rather than square, and a really nice thing to talk to the students about why that is the case. But obviously, ours is a rectangular window, not, as you can see here, pretty square, really. We can make it square by going zoom square, but then that will mean I'll lose some of these other values. So I'm not stressed about that. I'll be quite happy with this. Okay, so few students earned full marks with this question. Few earned 3 marks, which is, I think it's a real travesty. Many students just copy what they could see on the calculator with little effort to indicate location and behavior around the asymptote. It does say up here, and I encourage my students to have a highlighter pen with them to highlight things like this in the question, mark and label the position of its asymptotes. Okay, so there's something interesting going on here, which in the classroom context, it can talk about what's going on, why is there nothing here. Again, the table helps us a lot with this. Like Carol said, there's the 0 with the error, and there's lots of errors after that. So real nice discussion about talking about why all these errors happen over here and why there's no more values. So again, students know that they get an error at 5, so perhaps they'll want to put a hollow circle there to mean that it goes to 5 but doesn't touch it. Again, they can get their maximum if they want to, number 4. On here, if they want to find what that value is, they can find their zeros, as I've already showed. Mark those. They can see it off the graph as well, but they could actually just they could actually find the exact values of those if they want to, which I've already showed. I'm not going to show again. And it does give a massive hint that there's an asymptote. Obviously, what a lot of students did was just draw one continual line that went down and up, like a fishing hook. Well, yeah, a fishing lure. No, what do you call them? A fly fisherman's hook, I reckon. That would do. So we can see that really just rushing the graph rather than really thinking it through, which I think is just a shame. When they've got this technology, they've got the visual, to lose any marks here is just a real travesty.
John,
right,
just to point on that,
yep.
If I was setting the exam and in tests and things, I would certainly do this. I believe that for these sorts of students with this sort of question, which is a little bit different, they should have been actually specifically asked, what is the equation of any asymptotes? And I would always encourage students to write those down. The vertical asymptotes are, or the horizontal.
It does say it in the question, Carol. It does say mark and label the position of.
No, it says mark and label the position of, but I would specifically have part A of that was state the equations of any asymptotes, 1 mark.
Maybe. Yep. Yeah, I like it, and I like that. I personally like the questions they choose, because we, like everything, like a multiple choice question, we put questions in there that we know the wrong answer students are going to give. So, you know, like 3 squared, we'd put in the answer of 6, because we know some students are going to do 3 times 2. So I think that I like them choosing questions where they know their graphs are going to join like this, because we're looking to differentiate between those students who really understand what's going on and who are just carelessly led or just careless. So, yep, no, I get what you're saying, but let's have a look. So here is talking about the derivative. Not going to help us too much. It's just to show that. Again, talking about why is it to show that? Well, if you can't do this, you can still do this question. Notice it is a hence. So you have to be using this answer to solve part 2. The graph on its own will get you no marks. We have to use it. But the important thing is, I think that students need to bear in mind, is that they can still use the graph as a checker. So find the x-coordinate at the stationary point. So there's no reason why they shouldn't be still finding that stationary point. And really, they should have found it when they graphed it, really, in the first place. But if there's no reason why they can't have it there, so they know, okay, the answer I've got to get here is basically 3 1/3 and 2.9. Well, what are we after? Just the x-coordinate, so 3 1/3. I've got to get 3 1/3 here. If I don't get 3 1/3, I need to find my error. And that's really important that students look at their own questions and have the skill to work out where they went wrong. Again here, show that the graph has no inflection points. It's a show that question, so the graphics calculator won't be valid to get their 6 marks. A lot of marks here, and there was a lot of space. I've shrunk it down. But there's no reason why they can't get some nice visual clues from the first and second derivatives. So I'm just going to show you this. So again, let's keep that there. We've got plenty of space down here anyway. There's my y6. So I'm going to do the first derivative. So to do that, we use the quick keys again. There's the derivative. And we want the derivative, oops, gone too far. We want the derivative of y6, again alpha f4. This is the new operating system for both the 84 plus and the 84 plus CE. And we want it for all values of x, not just one specific. We're not finding a specific value for the gradient. We want it for a general case, so that's that. And we don't have second derivative, but we sort of do. And again, I think this is a nice little thing to get the students thinking, well, what it really is just the derivative of the derivative. So let's do that now, and that will be, I've done that wrong there, haven't I? That should be...
No, that's all right.
No?
Yeah, that one should have been Y6 at number 7. Yeah.
Right, that's what I thought. That's all right, good. I just picked that up. Thank you, Carol. So that will now be Y7, which is number 7. I don't use the cursor very much. For all values of x. Efficient again, Rodney, hey? Let's
Very
go
efficient,
across.
yes.
Go across here, alpha, and we want 6, don't we? There we go, number 6. There we go, looking beautiful now. I'm going to just do one at a time. And again, I think this is a really nice teaching tool. There's some great SACE questions where students have to graph the first and second derivative off of a line that has no equation. But there's no reason, again, in a classroom context where we can be using this to support their learning. So let's just have a look at the first derivative. And again, getting students to predict what it would be perhaps before we do this is quite nice. If we go trace, then we can talk about, okay, here what's happening. Well, this brownish one is talking about the gradient. Well, the gradient there, if we drew a tangent line there, is positive. So that's why this brown one is on the positive side. Obviously, at the top, which was 3 1/3, it was 0. There's 3 1/3 roughly 3 1/3, and we can see therefore that makes sense that it is at pretty much 0. So that makes sense that the gradient is 0. Going back up again and coming down the other side, but obviously the gradient is negative now, hence the reason why it's on the negative side. And why is it getting steeper? Well, the gradient's getting steeper. So again, we can look at that quite nicely. But the question was talking about no inflection points. I think that the graphics calculator allows the students to get some ideas if they don't know how to solve that question. So maybe they've left it out and they've just gone on and done the other questions, and they're going to come back and look at it again. They can use the graph to think, okay, what am I actually looking for? How am I going to find that there's no inflection points? I can see there's none, but how am I actually going to prove it? Okay, so the blue is the second derivative. Let's leave them all on there just to really go a bit crazy. All right. So we can see it goes off here.
You just like showing the pretty colours of the graph there too, John, don't you? Looking
beautiful.
At that.
Yep,
Beautiful.
I like showing that off. And again, we can see, well, oh, that's right, of course, that's right. The second derivative must be 0 if there's an inflection point. We can see it doesn't get to that. So how am I going to prove that? Okay, so I need to find the second derivative, and then I need to see that it proves not equal to 0. So again, using the calculator to support their understanding, whether it be in the exam, if they've got the time, hopefully they have, or equally in terms of teaching our students for future years and just this topic in general. And this was a question taken from 2015, a nice little question that is asking, again, couldn't use the graphics calculator, it was asking us to find the 3 equations, if I remember rightly, and then hence find the quadratic equation formula. But there's no reason. I'll just do this one quickly if I can. Just focusing on the time. I've got about 5 minutes. I'm looking forward to hearing Carol's part of tonight, so I'll make sure I save enough time. So we'll just do that quickly. We're going to stat, and we'll put these 3 points in. So the 3 points are -5, 1 and 3, -5, 1 and 3, and the y values were 7, 1 and -9. I'm going to go back into my format and get rid of that grid. I don't really like the grid that much. That's just me. So I'll get rid of that. We'll go to zoom, and do zoom standard. That's done. It's going to graph something at the moment, but nothing because all my graphs are turned off. There's no spiral here, and that's because I haven't got stat plot on. Let's turn that on. And they were in list 1 and list 2, and I do want a scatter graph. Let's have a look at that now. Okay, that's looking pretty good. That matches it pretty well. Now, again, a nice little thing to talk to the students about. Do we need 3 points to draw a quadratic? Can we just get away with 2? Do we need more than 3? Well, let's see how we go with this. Not a second. Just stat. Across the calculate, we want the quadratic regression. Again, with the new operating system, it's much easier to use. We haven't got to use, as we were talking yesterday, Carol, about the second plus or whatever it was. I can't remember now what it was.
Just see the syntax, yeah.
That's right. Yeah, it's much easier. We don't have a frequency of each. We're going to store that regression equation as, I think, quite high now. So let's go.
8 or 9, I reckon you're at.
Yeah, right. So let's go 9. Let's be on the safe side, and we'll calculate that. There we go. That's looking pretty good. I haven't got my R squared there. Well, why is that? Well, okay, if we go to mode, we can see that stat diagnostics is off at the moment. So again, being as efficient as I can, I'll scroll up, turn the stat diagnostics on. The stat width is already on, so that helps us with the syntax. That's now on. Let's quit that. And again, with both the 84 and the 84 CE, I can scroll up. Look at that, an R squared of 1, a perfect fit. There's my equation. There's the graph that I'm going to get. Beautiful, looks pretty good. So all I've got to prove now is that I can actually get those values. Those are the values that I need to get for my A, B, and C to prove this question. So again, using the calculator to support their answers, almost like a solutions book, in a page in the back of the book. So implicit differentiation. Well, this is seen sometimes as a non-calculator thing, and sometimes the examiners do choose questions. I really like the fact they find these questions, and obviously they have to because they're going to use implicit differentiation to come up with the gradients, but we can still use our graphics calculator on a lot of these. So what I've done with this one is rearranged it into a quadratic in terms of y, and use the quadratic equation solver, quadratic equation solver.
Formula.
Thank you very much, Carol. Good job, you're paying attention. To come
Don't
up with
rush. You're right.
with the 2 equations, and there they are. This one here, the first one here, and the second one, obviously because it's the quadratic equation formula, has now, those are the rearrangements. I'm just going to turn my other one off down here, which is the quadratic that I did a minute ago. I'm just going to turn that one off by pressing enter on the equals. But yeah, those 2 there. Now, would our students do this in the exam? I don't know. I think some students may, some students won't. But in the explanation of the implicit, and when we're doing past exam questions, a very nice one to get them to think about. And nothing wrong with getting our students to solve that for y anyway, and to think about it. But if we can now, and I'll leave these colours as separate, we could make them the same colour, so we just see one line, but I'll keep them as separate. And we'll go.
You might want to turn off the stat plot as well.
Thank you, Carol. Well noticed. I like that. We're going to go zoom standard, but before I do that, thanks to Carol, I'm just going to go number 4 and turn the plots off. A quicker way to do it. And we'll go zoom standard. Let's see if it will fit on here. Okay, not looking too bad. Probably zoomed in, I've zoomed out a little bit too much. We can see here that it's starting to lose it. So what I'm going to do this time is we're going to go zoom box. So a little bit slower on the emulator to do this. I'm not quite sure why on the emulator. On the handheld it's very fast. But if I hold the cursor down, which I can do, it all of a sudden seems to shoot about a million miles an hour. So It's a little bit slow, so just bear with me on here. There you go. Going to go zoom box. Oh, that's not bad. Oh, there you go. I must be getting better at driving this thing. There we go. Across we go. Ooh, that'll do us about there. Maybe if that'll do. I could go a fraction more down, but I'm not too worried for now. That'll do. All right. Enter on that. And here we go. There's that implicit drawn quite nicely. And if I zoomed in a bit more, this actually, on the one I did earlier, they actually will join together here as well. But it's no dramas, because now with that question that we're looking at, show the derivative, I can't do that. Find the equation of the normal. Again, they've got to find the equation of the normal. They've got to use this derivative, but we can still use the calculator to help us, to support our answers. Let's go into draw. Draw the tangent. And is it of the blue one? We want it at -1, -1. So yes, it is of the blue one. And we want it at -1. And there's the tangent being drawn. And there's the equation. Okay, so I should get an answer for this one when I chuck in -1 of -1 for the gradient. Again, just as a side point, I could, if I wanted to, get the students to use -1 and store it as x, taking the other -1. Because lots of times, obviously, what the examiner's looking for is to make sure that the students don't make a mistake when they got to do squared and everything of numbers. So we could do it like this. And then we could actually just type in this equation. So using the fraction button and typing in -2x y minus y squared all over x squared. Now obviously, because the calculator knows that those values are -1 and -1, we should get the answer of -1. There we go. So we get the gradient. And when we do solve it, we get the line of y equals x. So again, we'll get the students to graph that line on y equals x. This will be the equation of the tangent. Of the normal, I apologize. And when we graph it, and the students will say, hang on, it doesn't look like it's normal, because if that's the tangent, this should be 90 degrees. And I like my students questioning that and being aware of that. So obviously the reason is because it's not square. So if we just square it up, we may lose the tangent because it was drawn. In fact, I think we will, because it was drawn in. So no dramas. When we draw it, it disappears again, or we press clear draw and it will go as well. Let's just put that tangent back in on the blue line at -1. And there it is. Now that is definitely looking 90 degrees. Beautiful. Again, we can find the horizontal tangent because we can find the turning point on this graph here. And like Rodney said earlier, with the colors, and we're trying to find a minimum this time, with the colors it helps us nicely. We don't want the blue one. We want the red one, and we want it, oh, that's pretty good, isn't it? Just there, that will do us. I'm moving it just over here a little ways. Again, it will help us. It's -1 and y equals 2. So that will, again, help support my answers in here. There's another one that we can solve the same. I can just type that in, rearrange it as cube root. I won't do that because I'm conscious of time, but cube root is in here, or any root that you want is number 5 in the maths function on the calculator. And we have got another one that we would equally get. I'm conscious of time, I wanted to pass on the Carol, but we have here one that we can equally graph. We would set the window up correctly. We can find the x-intercepts. I will just, Carol, have I got just 2 minutes? I can just show this one?
No, keep going. Keep going. This is fine.
Thank you very much. So I'm just going to turn those two off very quickly. I'm just going to show this because I'm going to show you how we can use the store functionality. I think Carol was going to talk about this as well, but I'm just going to show you how we can use the store functionality in the integration part as well. So most of these marks, I think, for this question, if I remember rightly, were quite low marks. So that means that the calculator is allowed to be used quite a lot on this one. 8 minus e to the x plus 20 e to the minus x. Let's go to my window again. Between -1 and 3, going up by 1. All right, let's just leave it like that for now, see what that graph looks like. Okay, we can see that we need to adjust it. So let's just go to my table quickly, because that will help me work out what I need to go to. Wowzers. So it crosses there at 27, hey? So let's go to my window, and at 3 it crossed at -11. Okay, so we'll go to window. We'll change our minimum to -10, our maximum to 30. I won't bother by the Y scale, there'll be lots of dashes, but it doesn't matter. There you go, that will do it. It asks for the x-intercept. Okay, so second calculate. We know that's a 0. We know that that is just after 2, so if we go somewhere between 2 and 2.5, that will tell us the value. That's there. No, it's black because we're using the black function on the graph. I don't want you to think that something's happened to my calculator. We don't need to guess it. So there's going to be 1 there. There's the value. Okay, now the next question says to find the integral, or the area obviously under the curve. But to get that, the calculator now has wiped off the fact that I told it earlier that x was -1. It's now stored it as the new x value that it typed in. So that is that value there. Also the new y value that matches that as well. But I'm not interested in that one. I am interested in this one here, because I'm now going to store that as a letter. So I'm going to press store. I'm just going to store it as A. I encourage my students to write down next to the question where they stored it as, so they can lose track of what it is. And it asks for the integral. So we're going to go second, calculate the integral. And I could do it just with the alpha F2 and do it without the graph, but I quite like the graph. I like seeing it. I think you've worked that out about me. And upper limit is A, because it now knows the value. And it will nicely work out the value between 0 and A, which is what it wants here, and hence the reason why it's on 1 mark, and the efficiency of what the chief assessors were saying. And that is me. Carol, I would like to pass over to you. Are there any questions that came in, Rodney?
Well, there's a few questions about whether recorded webinars, and there's a few little comments. I've been chatting with them online as Carol's setting up her screen. John, you're showing lots of wonderful examples, and getting the students, if something goes wrong or they're not sure what's happened, they actually think on their feet, or sitting down actually, as they say in the exam, and where do they go on their calculator? What could they do? What skills have they learned? Where are the keypads to press, isn't it? So, Carol, we're seeing your screen at the moment.
Am I up? You're up. So we're right there.
Yep, you're right.
Okay. All right. So I've just got a few comments to add to the things John said about what was on the SACE website. So they'll appear on this PowerPoint at the right, just very quickly. John said this about the Chief Assessor's comments and the actual exam booklets as well. The report indicates what's been done well, what's been done poorly, and there are many comments about technology. Also, it's very important to note that this year is the last year for the current 5 mathematics subjects in Year 12, and new syllabuses and new names are now going to be available for the 4 subjects for next year. And just to push the Maths Association of South Australia, we do provide the revision guides for these, and we're in the process of writing new ones for next year. But a really important thing is that you do not rely on anyone's interpretation of the syllabus statement, not the revision guide, and not even the textbooks. You really should ensure that you're aware of the very significant changes that are happening and the new material in the content. Many things are in, many things are out, many have just shifted sideways to a different subject. So you do need to be aware of those. In terms of examinations and assessors' comments, specifically in 2015, question 6, the examiners said there were many good responses, but the poorer responses showed evidence of major difficulties with constructing real quadratic factors and providing reasons for working when asked to show a result. Now, that could be seen as evidence of weakening algebraic skills. I think that is probably the case because we have less time spent on mathematics in earlier years, but I don't think it's the blame of using the graphics calculator, because as John has indicated really, really clearly in the last half hour, discerning use of the technology is what is really important. And as a tool for conceptual development, the graphic calculator is incredibly valuable when it's used appropriately and in a discerning manner. So just to look at a couple of questions, we did say that we'd have a look at iteration, and of course most of the work on iteration is going to be ditched for next year. If you're not already aware of that, you need to have another look at the syllabus that's coming, but just to show you it's still relevant for this year, so some very simple little examples. In this particular question, actually I might not do this, I might just move on since time is going very short. There was a very simple example, but there was a table of indeterminate length to actually ask you to describe the long-term behaviour of this little iteration. And what I found was that when you start using your home screen to do that, you store a C and you put in 0 as a seed and you square it and add on C and keep on going. If you change to perhaps 2 or 4 decimal places, you actually see evidence of the sort of behaviour far more quickly than you leave it on floating, than if you leave it on floating. So, but I won't bother to do that one. I'll have a look at question 13 in the specialist exam from last year. And as the examiner's comment says, the opportunity for informed use of technology, and the students responded well if they took that. They produced pleasing graphs and used them to determine the relevant quantities correctly. Some students substituted in the wrong places, but you'll see that. And in my view, if you use the calculator really well, you can get up to 10 marks out of the possible 15 for this particular question. And so this is question 13. The age of a razor clam can be estimated by counting the number of rings. And so it gave a differential equation. And it's very easy to miss the fact that this has a y in here as well. So in fact, it's quite a lengthy process to actually use integration and get the function. But the next part of the question, get in the right part of the screen, the next part was to actually fill in this slope field, and I think students find that incredibly hard. This one needed to go through the point 510, which is not on any of the particular points, possibly that one. You can more or less follow it through there, but you're not quite sure where it goes to. And I think students can worry about that. The examiners like to make sure that you go through the point they give you and that you don't cross any obvious slope lines, so then they'll give you 2 marks for that reasonably easily. But what I think is important is that if you couldn't see where the curve was going, the fact that in the second bit of the question you were actually asked to solve the differential equation and come up with the formula why it was 15.7 e to the blah blah blah, not very clear to read there, you could actually then graph it and have a look at some of the points on it and transfer that back to your slope field in the answer booklet. So hopefully this has set itself up. There it is, that's the graph of it, and if you transfer that onto the slope field, it actually comes up quite easily. The next bit of that question was find with reasoning the approximate limiting value of the length of the shell. Now, this is the formula for y, the length of the shell. If you use your calculator, you can see that it's obviously heading towards something fairly straightforward. If you look at your table of values, you will see that it fairly quickly approaches 15.7. And you need to get students to be able to play around with this enough. Clearly 15.7 is going to be the value, and they can have a look at this function over here and say, well, why is it the 15.7? Well, it's clearly got to be because this right-hand part with the 2 e's sitting in it must be approaching 1. Now, apparently there were 2 marks for this answer, but you needed to say first that the limiting value was 15.7, but you would not get marks for reasoning unless you indicated that this part, e to the 1.2 minus 0.4t, actually approaches 0, therefore e to the 0 approaches 1, therefore the limit is 15.7. But it's clear on the graph that that is the case. The other 5 marks for this question can be done actually using the calculator, and it was draw the graph of dy by dt on the axis in figure 16. Now, let me just go to my second graphical database. I've stored this already, so I want to recall it. So number 4, recalled graphical database number 2. What this has done for me is come back to this function that I had before, but the derivative in there and the other bits that I need for this question. So they're already in there, and I also will have changed the window. You notice they're turned off, and so this is the one that's turned on. So this is the graph of dy by dt that should be popping up now. So there's the graph of dy by dt on the axes in figure 16, and the axes were actually given in the question, somewhere between 0 and 10 for x and 0 and 4 for y. Graph the derivative and find the approximate maximum rate of change of the length of the shell. Now clearly that's the maximum of this particular function, so we're going to calculate the maximum, number 4, and we're going to go between something like 1 and I'll put in 6, that'll do, and away it goes. And so again, the maximum is at 2.31. Now, John mentioned this very briefly before. The number of decimal places there are related to the pixels. Probably the value we're looking for is exactly 3, and I think the examiners assume that quite happily. So the maximum rate of change is going to be 2.31, whatever the units are. Yeah, centimetres per year at t equals 3. The other question was find the approximate length of the shell when the rate of change is a maximum. Now, many students apparently substituted t equals 3 into this and got the 2.31 again, whereas in fact the length of the shell is y1. So what we need to be able to do, second quit there, we actually need to be able to calculate y1 at the value. Now, the last x value that was in there was 3, and I'm just going to try this, John. I'm just going to put x in there and see what happens. And yeah, it did it. The x that was stored last in the calculator was that value that I was looking for, and it gives me the maximum value as 5.77.
That's nice, Carol. Nice touch, that.
Yep. So that's worth knowing about, I think, usually. But and the other thing that was really interesting, I think, for the students is if I go back and turn on that graph and come down and turn that one on and turn this guy off. Graph again, I think my window is going to be all over the place, so I'm just going to go from, okay, this is something quite nice to show once that's finished. So I'll go into the window and go from 0 to 10 is probably all right, but it's the y values that are the issue. I can't remember what that goes up to. Let's put 20 there and just see what happens. Yep, that'll do it. Now, the interesting thing on this one is that the maximum value on this guy, which is the derivative of this, is in fact at the same place as the inflection point up there. So if I do the maximum, number 4 again between 0 and about 6, 5 maybe. We're heading into that. No, that's not gone properly. What's gone wrong there?
You're on the wrong
let's
curve.
try again. I did something wrong with one of my values, I think. I'm looking for a maximum. It was on the wrong graph, wasn't it?
Yeah,
so I'm looking for the maximum, but not on the blue one. I actually want it on the other one. So my left bound is 0. My right bound is about 5.
Carol was saying before.
That's right. Again, the colour is just beautiful. We're working on it. And so the maximum is at 3 and the y value was 2.31. But the interesting thing is it's right up here where that change of curvature happens. And I always tend to talk about inflection points in terms of curvature changes. And so we change from being a convex or concave up, some people call it. I call that convex, this concave. And so at an inflection point, you've got a maximum point on your derivative graph or an inflection point on your function graph. So that's quite neat to notice as well. Moving on really quickly, question 14 in the specialist maths paper offered more opportunities to use the graphic calculator if students knew how to use the calculator in sequence mode, and I suspect many probably didn't. This is quite a hard question, but only a couple of marks were really for the iteration part, but I think it's nice to be able to show this today. So we'll go to graphic database recall number 4, enter that, recall number 4, there we go. So y equals. Now this takes me into, in fact, sequence mode. You will notice in this screen that I'm over here in sequence mode. And so go back to my y equals. This is a messy looking question, and I don't think there'd ever been one like it before last year, because the differential equations had to be used in the next bit, because you had to use Euler's method with xn plus 1 equaling xn plus h lots of the derivative value, where the derivative was given by these two little formulae. And so if I go back to the calculator, you'll notice that here I have un. That means the next term in my sequence is going to be calculated. That'll be the xn plus 1, in fact. xn plus 1 in here is un in this one. So you find that by doing u of n minus 1, that's the previous x value, the xn. The h values in this question were 0.1. If you're not familiar with it, you can have a look at it later. But 0.1 multiple of dx by dt, where dx by dt in fact is 4 times the x value minus 2 times x multiplied by y, which is now v. Now that's really very messy, and it asks you the minimum value, that was 3, and the y value was 1, and I put in the v value in exactly the same way. Now that is really asking the students quite a lot, and I've checked with a few teachers who suggest that when they've taught this work to their students, they actually leave it set up in a form something like that, so that students can go back in and modify it really quickly. And it's easier to cut bits out than to go back adding things in, because if you haven't got very good eyes, you probably won't realise that when you press second 7, you get the u value when you're in sequence mode, xt, theta and n is the variable, but u and v, which are second 7 and second 8, the u and the v are those little blue guys up there, and they're quite hard to find. But then you were confronted with a hideous looking table like that you were supposed to fill in. Now this requires you to fill in all these bits at 0.1 intervals going down the column with some 10 iterations. Now the examiners only wanted the last couple of bits from here, and most students couldn't get that. And I think students need to be told, make something up, look at the diagram and have a bit of a think about where it might be, and make something up and put it in there so you can go on and do the rest of the question. Now in fact the table turns out to look a bit like that. Now where does that actually come from? Well, if we go back over to the calculator, once you've finished your sequence information, you have to go to either graph or second table. If you go to second table, it's now working on it quite slowly because it's reasonably complex, and it'll come up with a table of values sooner or later. Of course, the question asks for these bits as well. Now, this is, I just might go to table start I'll make that number 1. Second table, go back and do that again. The question is asking for these bits, which can throw kids a little bit if they know what these are. Well, here's x equals 3, y equals 1, and the first values were 3.6 and 1.6. Well, here they are on this table. The second one, 3.888. Well, that means I needed to transfer this guy up to here, this one across to there, and this one over to there, and so forth. And that's not totally intuitive for the students. So you've got xn and xn plus 1 in your table, but these are the ones you wanted down at the bottom. That 0.03 for x and 1.43 for y are the values that they were really looking for in the question. So the other little thing I can show you very quickly too is that you were then asked to put the points which related to x equaling 1, y equals 1, which is the 0.03, 1.43 onto here. So 0.3 down here somewhere or other, and that's not at all obvious to the students either. So it's rather nice that if you look at, I think it's format, yeah, if you look at format, you can actually go into the UV mode, which I've put it into already, and you can actually plot a heap of points in UV mode because my variables are U and V rather than X and Y. And if I graph that, a series of points actually pops up. And if I trace them, here they are. The x equals 3, y it was 1, when n was equal to 1, and I can flip around there really quickly. Keep going. And here's my last one that I was looking for, the 0.03 and the 1.43. This is the guy that I need to plot somewhere in about here on that particular graph. And I don't think many people take advantage of this either. I could probably redo that exercise, making that h value less than 0.1. If I changed that to 0.01, I'd get a whole lot more points, and I'd probably get a graph that looked pretty much like that as a scatter plot. But that's quite a neat little question, I think, if you know how to do that. So there's a whole lot of information in there, and there are a lot of questions in our exams that ask you to show something or other, and I think that students need to understand what the examiner's lingo is, you know, what they're asking for. Find the exact value of means you're probably looking for a third or something like that. If you're asked to show something, then you really generally need to do it algebraically, unless you're pretty slick with your graphs and your calculator and get enough evidence down to show that you really know what you're doing. But I thought that you'd like this little thing to finish off on. One of my students years ago produced this. He thought it was a good idea to have what he called the Thingo theorem. And that said that if you're asked to show that something is true, it probably is true, so therefore it's proven. And so, for example, consider this nice polynomial. Show that x minus 3 and x plus 3 are factors of f of x for all a. As the question asks us how to show that the statement is true, then it obviously is true. So x minus 3 and x plus 3 are factors of f of x for all a, QED. Okay, I'll leave you with that just as a light note to finish off with, and say thank you very much, and hand back to you, Rodney.
Yeah, thank you, Carol. The Thingo theorem always works. Does the students show that it's true? That obviously is true. You just got to make a little bit of work.
Precisely. So you just have to quote the Thingo theorem. Anyway,
I'll remember that from now on.
Yeah.
Maybe in future years the SACE exam will say everything except for the Thingo theorem being pre-used.
Except for the Thingo theorem.
Yeah, exactly right.
Watch this space.
So we look at it there with if you're looking for extra resources and where the webinars are. So if you go to education.ti.com, and if you're not sure of the website, do /Australia, come to the TI Australia website, and you can look across at the tabs, look at all the resources you might wish to find. As John demonstrated last night, downloading the software and the upgrades to the 84. Now people were asking during the night, the participants, where are the webinars. So on the home screen, one way that I navigate to is actually down the middle here. Click on the webinars, and you'll see that the upcoming webinars, here we are now, and then next one at the moment, there's still planning stages, there's a few webinars coming up which calculators is right for your school, and as the question was asked during the night, whether the recorded webinars, you click on the demand tab, and there we are there. So you'll see lots and lots and lots of recorded webinars.
Oh, was that last night's up there already?
Yeah, it's already. How efficient is that? With that in mind, if you look at the YouTube channel, and you'll see the TI Australia YouTube channel, they have also put up your webinar last night on the YouTube channel. But you'll see in front of you, you'll see the West Australia Application Exam Series, and you've got other recorded webinars, and there's so many there, and if you're looking for things for your students, for yourself, so it's all there. It's actually had a number of hits today, the webinar last night, Carol and John. So just a reminder to the participants to complete the survey at the end of the conclusion, or the conclusion of the webinar, and check your email. In a day or two, you'll see an email with a link to present your certificates for PDs. And so thank you, Carol.
Thank you, Rodney, and thank you, John.
Yeah, thank you, John.
Yep. Thank you, Rodney. Thank you all. Thank you for listening, everyone.
Yes.
All the best.
Thank you for listening. Yeah, take care. We look forward to your participation in future webinars.
Okay. Bye-bye.
Good night.